Okay, so we move on to a different customer, and it is, we did this gentleman's Moonraker Master, which was problematic, if you remember. A few weeks ago, they'd been messed with something chronic. Now, where's my pen gone? So this is going to be Binatone Long Ranger 40. Now, this may have the gift box inside, but this may be the only box. Sometimes when these were shipped mail order, and a lot was sold mail order by places like Grattan's and so on, this is the only box you got. Now that yeah, this is the only box. So I'm not even sure if I've seen a gift box for a Long Ranger 40. Right, it's got the dummy batteries, it's got the carry case. That looks absolutely immaculate. We'll take it out of this. Port in the case. Of course, if you buy one of these with a broken aerial, what are you going to do? Because you're not going to get a replacement aerial. Exactly the same as the Long Ranger 6 and 12. The only difference is the number of channels, and on the 40 you get the LED display as far as this. You also gain this on the side. You've got I think it's just charge you have on the 6 and 12. You end up with mains adapter. 450 milliamps is absolutely bonkersly wrong, if that's the way you can put it, because it's 900 milliamps. All it's going to do is current limit and not work properly. And because of that, you think, oh, we only need a thin bit of wire, but no, we've used one of Mr. Chippie's ones intended for Midland 77805, and it does tell us it's positive centre. So we'll look at the battery compartment. It's got the 10. I mean, sometimes I've seen these on eBay with the battery thing missing, and they've got it on a PP3 9-volt battery, and a good working order. Yeah, right. We've got replacement ones of those. It's a standard part. We've got the 8s as well for people using throwaway batteries. You need 8, or you've got to use dummy batteries. Here's the logic. Throwaway batteries are 1.5 volts per cell, and rechargeable batteries 1.2 volts. So with 10 rechargeable batteries, 10 times 1.2 is of course 12, and if you did that with 1.5 volt batteries, you'd have 15. You'd blow the setup, hence the dummy batteries. So, shall we try it as it is? Let's pull this telescopic aerial up and make sure that it's in one piece. It's broken. It is a broken aerial. So that's going to be very frustrating, because I'm sure that the owner doesn't realise that. Always check these things. I'm going to very carefully pull that section out, insert this one back, so it gets to there and it's broken. So I don't know what plans he's going to have. There's absolutely nothing I can do to help him on that. So 1, 2, 3, 4, 5, 6 sections down, the aerial is broken. How do people do it, you know? That is so disappointing. Anyway, we'll get on with the set. I said to him, have you got a Binatone Ranger 6 and 12? And he says, no, they always seem to have broken aerials. Well, this has. Tell you what, we won't unscrew it any further, we'll do the test. So because you've got external aerial, we can actually run it properly into the test set. We're going to use this type of adapter. This is a Motorola adapter. It looks like a phono, but it's longer. It was used in car radios in the bygone era, and also in scanners back when they were crystal controlled. So like the Realistics, they're lossy, but that's convenient and probably cheap at the time, which is more to the point. Right, this is a 12 volt radio if I remember rightly. Let's just put the power supply on at 12 volts. And the display on. I'll tell you what, let's actually connect it to power. It's a bank holiday today, which means the banks are on holiday, which must mean they're not charging any interest on mortgages. Well, that's how it should work. Can't be bothered to go to work. Right. So we're connected up to the test set, picture in picture on 2.5 watts. The clipboard is not, we'll use this yesterday's Route 66 manual to lean on. 2.5 watts, expect 3.5 to be honest, it should be somewhere around there. I'll have to check what voltage these can be applied to, I can't ever remember. Low power, 180 milliwatts. Back to that, 556 milliamps. Channel 40. Looks like 2.6 watts there. Channel 1. 2.5 watts. Deviation for what it's worth on this test set. Wallow 1.5. Frequency, gear's been on for more than an hour, and here we go. Let's look at the frequency counter. 79117, that's very, very close. Should of course be 2779125. So there's no meter, good, which means there's no PA, there's no meter, there's no meter lamp. The switches work, the potentiometers work, and we haven't tested all the sockets yet. The microphone works and the speaker works. So let's dial in 2779117 to the signal generator. That'll do. I hope we can get it better than this. So into the test gear. It is 4.3 microvolts. Four microvolts, and 8 microvolts. Squelch. 100 microvolts where it wants to be. And minimum squelch. .4 microvolts. I don't think this would get to scratchy corner. So what's happened to the receiver? Is this another mystery? Had everything twiddled in it. These are fun to put back together, folks. So like the 6 and the 12 models, they are synthesized. It's a sim obsolete synthesizer. It was obsolete when these were made, and if I tell you what it is, because I won't remember, MSM 5807, and these were obsolete when these sets were made. I think that the people who made this for them had got a bucket load of them. It's a general purpose synthesizer, so it uses crystal mixer, so our receive and our transmit are going to be separate. If I remember rightly, the speech processor is down here. Sets are crystal filtered, and so the 6 and the 12, because they're the same chassis. So RV3, you can get at it there for the deviation, which is quite handy, not having to take the board out. There's a lot of wiring under there for the display. So we've got 10.24 reference crystal, and then we've got 26.3 something or other there. Surely that's going to be receive, isn't it? I'm sure it is. And that's going to be transmit. So I think we'll start by putting it on frequency. Our transmitter, of course, is up there. Our receiver is, of course, here, and that's going to be our detector. We're not going to touch these VCO things because although we've got a very poorly drawn, hand-drawn and badly photocopied circuit diagram, that's all we have got. So, very reliable though. Number of ones with an actual fault have been probably 2, and I'm talking about the 6, the 12 and the 40 there. Very reliable. So the recommended price on the 6 channel one was $49.99. The recommended price on the 12 channel one was $59.99, and the recommended price was on this one was $89.99. So you can see this cost a little bit more to make because it's got the channel display on it and not just that rotary switch. But here's the thing, it's the same set. So a 6-channel rotary switch surely isn't any different in price to a 12-channel rotary switch. There could be possibly a little bit more wiring. So I'll bet you this, I bet you that they're selling the 6-channel one at $49.99. I bet that was a loss leader. They're hoping you're going to have the 12-channel one or even the 40-channel one. So there you go. It's a bit like Amstrad's CB900, which he lost money on every set sold. Right, frequency. So we'll stay on here. Let's make sure the set's switched on. We're on channel 20. And I've got to try and guess whether... I think it's the inner one for transmit. So we'll go with transmit now. 2779118. And that doesn't appear to be affecting it, so we'll go for the other one. Okay, so 2779126. What we're going to do is the outer one is transmitted, the inner one must be received. We'll get our little Chinese thingy. And by that I mean signal generator. And we'll do the receive. Oh, we have to unplug a printer to do that. Right, so we need to get our signal generator spot on. So 2779125. Because transmit and receive are not a common frequency set. So I need enough signal to hear this. Then we're going to turn the tone off. So I've just got the carrier coming through. I'm going to turn the volume up a bit more. So you'll hear if I turn the signal level down, it starts to get hissy, so that's what we're looking for. I'm going to switch this signal generator on, and we're going to put 10.695 loosely coupled it's about there. So we've nulled that. There's just the slightest bit of motorboat there. That's quite near enough. So if I change the frequency on this signal generator, you'll see the effect. And the other way. So we're now on frequency. So be clear, this is a secondary signal generator on 10.695. I'm just loosely coupling it so the IF picks it up. We've got the main signal generator on the correct frequency. So the signal generator, the main one's correct, this is correct. So the only thing which wasn't correct is the crystal trimmer there. So receive was the inner one and transmit was the outer one. So we now know it's on frequency. So I'll unplug that. I'll plug the printer back in, which will then tell me You didn't shut the printer down properly. Don't do it again. Right, we'll put the tone back on. So I think we'll start with transmit. No, we won't. We'll start with receive because I want to go and see what the maximum voltages we can apply to the radio. So let's look at the detector next. So it's camera 3. So I want to try and get enough volume for a decent signal. Got 100 microvolts equivalent. Detector. Was absolutely spot on. So look at the IF. That wasn't spot on. I'll just have to turn this squelch down. No, that is that volume. I don't know which one I'm doing. So there's our peak on that. That was quite a bit out. See what we can do with the receiver. I think we're going to have to take off the rod antenna . Go through this again. Drop the signal. Well, it's not good, is it? 1.2 microvolts. See, some of this is the aerial dragging on it. One microvolt. Two microvolts. I mean, that's usable. I think it's going to be better in real life than into the instruments, because I say you've got, you know, you can see how easily I can affect that. Even holding the chassis is going to help. Right. I think we'll connect it to the deviation meter. I'll just see what the deviation is. Now this is the difficult bit. I'm going to disconnect some of this because it's on the bench behind me, and that isn't fun to do this. Wow, that's over the top by a long way. Let's turn that down. I think some numpty's got that at full. Because obviously it's going to work better, isn't it? Wallow, wallow. You couldn't make it up, I tell you. Let's break the aerial and turn the deviation up. And then put it back in the box, all innocent. Right, I'll go and look for the instruction book, and we'll just see what the maximum volts are that I can apply to the radio. So at the moment we're at 12 volts, and let's just go into transmit and see. Now I've taken that aerial off. Yes, it is 0.2 higher, it's 3 watts. Okay, hours and hours later we've got this. Right, what does it say, volts wise? Well, it says 12 volts there. It's at least 450 milliamps, so let's see what the current is. It's 634 before I've even tuned it. I don't know where they dug that idea up from. I mean, it doesn't even say plus and minus a percentage there, so we're doing this at 12.8 volts. That is as high as I dare go. It's supposed to be better than 1 microvolt. Right. Transmitter, here we go. So we'll now go on to the bigger scale. So we're now on the 30 watt scale, so we're down at the bottom here, and it's doing 3 watts. Just run through these, make sure. Oh well, there we go. Somebody's tweaked it down, haven't they? They're good at that. There we go, 4 watts. Just want to retrim transmit. This thing's warmed up, it's just moved a little tiny bit. Okay, so we're now doing 4 watts. Here's the faff with it all connected to my test gear. Let's go through the other channels. Channel 40, 3.8 watts. Channel 1, 4 watts. That'll do. Right, let's get that disconnected. Now, this is such a faff to put back together. I mean, back in the days when I had a television and the program Little Britain was on, and there was that carer and the chap in the wheelchair, and he would say it's a bit of a kerfuffle, and yeah, it's a bit of a kerfuffle putting these together. You've got to make sure that the push to talks, that you see, if you do it like that, that's going to fall inwards. It's naturally going to want to fall inwards. So it's got to be put together so that the bottom is that way on. So it's got to be PTT to the bottom. But at the same time, do you know what? We've got to put the aerial back, haven't we? I'm so disappointed this is broken. Right. So as I was saying, we have to get this in. We've got to get that in the guide rails. And at the same time, got to make sure that grommet's the right side, and you've got to make sure PTT goes in the guide rails. I've had another idea. Are there any? Can we get that in the guide rails first? I wonder. Is that the way to do it? I've only been doing these for 40 years, so I've not got the knack to it yet. You know what? That's probably a better way of doing it. Now we've got to get it all in the guide rails. Right, well, so far so good. Now something's stopping it just here. Ah, that's not in the guide rails there. Hooray! We're in. I wonder how many people took these apart themselves and actually couldn't put them back together. Right, we'll try again. Hey! Right, we'll plug the aerial in. We'll go to 19. That's on the test gear. We will plug the roof aerial in. Turn the test gear off. One on a Roger. There we go. So we'll leave it at that. We'll do an on-the-air test later, and let's hope it goes round scratchy corner okay. It's not as sensitive as I'd like it to be, but it is bearable. So thank you for watching the kerfuffle of putting the Binatone Long Ranger 40 back together, an immaculate set hiding a broken aerial.